Hi students, let's see about the momentum and the wavelength of a photon. We know that the linear momentum can be given as P equivalent to mv, where m is the mass and v is the velocity. For the quantum of the light, the linear momentum can be expressed as P equivalent to h nu divided by c, where nu represents the frequency, h is the Planck's constant and c is the speed of the light. We know the relationship between the wavelength and the frequency, that is lambda is equivalent to c by nu. If we substitute the lambda value, then the momentum can be expressed as P equivalent to h divided by lambda. So these are all the equations which relates the momentum with respect to the wavelength or frequency or speed of the light or mass or velocity. First, the momentum values. Next, let's go for the wavelength, lambda. Lambda can be expressed as h divided by p in terms of the momentum. So substituting the momentum value, lambda equivalent to h divided by m into v. But we know the velocity of the electron with respect to the potential can be expressed as nu is equivalent to root of 2ev divided by m. So if we substitute the velocity value, then it becomes lambda equivalent to h divided by m into root of 2ev divided by m. So if we again extend the form m to root m into root m, and if we cross the m which is at the denominator, then we'll get lambda equivalent to h divided by root 2emv. What are all the terms in it? H, the Planck's constant, 2 is also a constant, E is the charge of the electron, and m is the mass of the electron, and v is the potential. So by substituting all the constant values, we'll get lambda equivalent to 1.227 divided by root v nanometer. Nano represents 10 to the power minus 9. If we substitute the nano in terms of Armstrong, we'll get lambda equivalent to 12.27 divided by root v Armstrong. So what are all the equations we are having for the wavelength? Let's go for the cumulative. Lambda equivalent to h divided by p. Lambda equivalent to h divided by m into v. Lambda h divided by root of 2 into m into e into v, and equivalent to h divided by root 2 m pi o, where pi o is the work function, equivalent to 1.227 divided by root v nanometer, that is equivalent to 12.27 divided by root v Armstrong.